So let's start with the revision. So what are things we have done in the last session? We have updated the environment, top module for all SDRAM testers. We implemented register model. What did we do? We have implemented register model. So what is that register model has? Can you please make a note of points? What all things we did in register model? So we understood that design basically implements registers as reg 31 down to 0 CSR, whereas same thing in test bench is implemented as class. So I would write it as class CSR end class. You know that by now, after having completed system Verilog language, you know that there is always a benefit of viewing something as a class rather than as a reg that you want to do. What is the problem? Let's say if the CSR has some fields. To refer to the fields, I have to say CSR of 25 down to 21. I can't refer by field name. I can't refer by field name. Whereas here, we can say CSR as CSR instance, let's say, register. Let's say I call it as CSR reg. Let's say I call it as CSR reg as CSR. So we instantiate it as CSR dot field name. We can refer like this, field name equal to 10, which is not possible. Which is more readable? This one is more readable or this one is more readable? Can you tell me which one is better, first one or second one? So second one is better, where you are able to access the directory fields by name. Okay. So that is what it does. So how do we implement register model? We define all registers as classes. Implement two methods. Implement two methods at least. This is at bare minimum. More methods if required. What are the two methods that we have to implement? Can you tell me? Read, write. Read is used to read the value of the register. Write is used to write the value to the register. Is it clear? Now all these registers, all these classes are what? Register definitions are instantiated in topmost register block. So in this case we'll call it as class MC reg block, end class. So in this you instantiate CSR reg as CSR, base address mask reg as BA mask. Like that, instantiate all the registers. TMS0 register as TMS0. Like that, you do all the registers. Then you here also implement two methods: function write reg, function read reg. What will you do in these registers? What you do is you pass address comma data as an input. End function. What you do is here, you based on the case address, you pass you decide what you want to do. Let's say if the register is 04 means BA mask dot write, something like this. Write the data. This is what we have done in the last session. Then we similarly we implement what? Function and function read reg also. Any questions you have here? Then what did we do? We learned how to integrate register model into test bench. So how do you do it? You instantiate in reference model. Then you start using it. We can directly create, allocate memory. Then you can start using the register model. Okay, that is where we stopped our last session. So what did we do? If you go to reference model, MC ref, what did we do? We used this register model to decide which register is being accessed. Which chip select is being accessed. Once chip select is decided, we use that to decide what is the memory type, memory size, memory bus width, write protect, bank address select, key pro open, parity enable, all these things. We will work on these things further, but right now let's try to close other memories. Let's try. Then what did we do? If the write protect is 0 means what? Write is enabled. Write is enabled to the chip select. To the target chip select. Write is enabled to the target chip select. In the target chip select, we again check what is the memory type. Based on memory type, we decide what type of, how the conversion should happen. So it will involve, I mean, when we say reference model is complete, we will have to change we'll have to do lot of improvement in this code. That we will do, but for timing, let's try to target other type of memories. So like we see, we have targeted top all SRAM. Top.sv targeted what? All SSRAMs. So we'll have another thing called as top all SSRAMs. Now, as you know, this code itself is nothing but top all SSRAMs only, actually. So you can just copy paste here. I mean, what I did, I just copied this code because in this case, anyway, we are doing all SRAMs only. If you go up, we are writing a generate block where we are checking only all SRAMs only. For 0 to I equal to 0 to 8, all SRAMs only are checking. This is SRAM only, SSRAMs only. Now, similarly, what I will do is top all synchronous chip select device.st. SCSD means what? Synchronous chip select device. Now again copy paste here. What I have to do is you just go here and change this code, remove this code. Here instantiate chip select, I mean the synchronous chip select device. So I'm not again going to refer to the PDF. You can refer to the PDF and do the connections. In my case, I'm going to refer to the previous project, and from that I'm going to get the connections and use that. Where you should see. Yeah. This is SRAM. This is SRAM. SRAM. No, all are SRAMs only here. Yeah, here. This connection. Line number 314 to 322. Y9. If I take, just paste it here. So all you have to do is what? Just go and change it to 9. That's all. Everything is same. Now only one thing I have to ensure is I'll open one more memory. These connections have to be properly given. Clock is coming from where? mpif.clock. It is not MC clock. It is what? mpif.clock. Address is what? mpif.address. Address. MCDQ is what? It is not MCDQ, it is DQT basically. DQ underscore T. MC chip select is what? MPIF dot MC chip select O underscore this one. Write enable is what? Sorry, let's go here. Write enable is this one. MPIF dot MC write enable this one. This is also output enable OE. Okay. Acknowledgement is what? MPIF.MC ACK I. Let's see here. Okay. So with this, all the connections are done. Now, is it enough for my test? Sorry, synchronous chip select device. Okay, now what I have to do? I have to go to the Wishbone generator, create one more test case. Let's close other topics, other things which are not required. Top will close, top all SDRAM will close, top LSSRAM will close. Go to Wishbone Gen. What you do is, like we had a test case for all SSRAM, you create another test case for all synchronous chip select device. You define a method by name synchronous chip select device. Okay, now the way you have created this test case, all SDRAMs, what you do, you create all SSRAMs. Line number where to where? Let's take line number 70 to 105, 70 to 105, which is 135. 72 105 Y35. You change it to SCST. So now you have to see, do I need to change anything in CSR? No. Anything in BMS? No. Whereas in this register I have to change, of course. That further, let's again open the spec. Okay. Now go to the registers, go to CSR register. In the CSR register, what is the first thing? Selection I don't need to change. Parity enable, it doesn't really matter because for this device it doesn't matter. Only one thing I'll have to change is key pro open, everything is same, memory size is also same, bus width is also same. Bus width is what? 32 bits worth, right? Bus width is which position? 5 down to 4, which is this one. 5 down to 4 should be 2 1. What is here? It is 32 bits only. Yeah. Only memory type I have to change. What is memory type here? It is synchronous chip select device. So what value should I use in memory type? What should be used here? Please check this and tell me. I should use 3. Rest everything is same. So timing selection register. So now this has to be completely changed because this was for SDRAM. This have to be changed completely. So let's do that. In the timing register, that is actually there in the operations block. There will be one synchronous. This is for SDRAM. This is for asynchronous. This is for synchronous. You see there are 4 fields. One is timeout, 24 down to 16. So that means 31 down to 25 is what? Now how many bits are there? 8 bits are there. Yeah, not 7 bits actually. So 70 B0 because they are reserved. We are not using them. 31 down to 25 we are not using. Let's say timeout we give as 100 decimal value. How many bits are there? 9 bits are there. 9 tick D 100. I am writing decimal 100 with 9 bits. Next, TWR is what? Write pulse with counter value. Let's say we keep 4 tick H4. TRZ means read to Z counter value. Let's say we'll keep 4. 4 tick H8. Mean 8 is the value. Let's say we keep it. Last one is 7 down to 0. Read to data valid counter value. Let's say we keep it at, ideally speaking, this should have been referred to the our memory, and from there we should have got the values. For timing, I'm just keeping something in between. 1 0. Let's say we keep it. That's all. If you do this, ideally it should work. This test case should work. So which is the test name I'm doing for that? All synchronous chip select SCST. Now what I have to do? Go to run.do, somewhere run.do should be there here. In the run.do, just change this to what? This one. Instead of top.sv, run what? Top all scst.sv. That's all. Nothing more I have to do other than this. Question. Okay. CD VLSI material A SP Labs February memory controller. Sorry. No. Sim. Do run dot run dot to should be fine. Yeah. So there is some issue. Work is not there, so we have to create work. Dmap work. Oh, sorry. Do run dot to. Let's say this completes. How do I check that this is working fine? What is the checks you have to do is basic checks is notes. Ensure that all required memories are connected properly. Memories are connected properly. That means only synchronous chip select device should be connected, nothing else. And ensure that register configuration is happening properly. Ensure that memory write reads are happening properly. This is a basic check we have to do. I mean, we need to ensure that the basic things are going fine. No. FSC. This is the register programming that is happening initially here. All the register programming is happening. Then are we writing to the memory? We are writing. See here, we are writing. It is reaching the data also. In fact, whatever you wrote, that same data is coming also on MC data I. But is it only one transaction that we generated? And what I am checking is, are we generating only one transaction? Generate transactions. What is the number of transactions we are doing? Here, number of transactions we are doing. What is the number of transactions in MC config? Let's see. If I go to MC config, MC CFG, what is the number of transactions? Number of transactions is 1. Okay, that's the reason. So how do I set the number of transactions? Go to top, all ST, SC, ST. Here we can set it actually. You can write here initial, begin, end, dollar value, dollar plus args, num transactions equal to, let's say, 20. You read it directly into MCCFG num transactions. So what did I do here is, we confirm that yes, one of them is working fine. Now which one is it happening really? If you check chip select, you will come to know where it is happening. It is happening to chip select 2. On the chip select to whichever memory connected, the synchronous chip select device connected, there it is happening. There you wrote, you can see the value you wrote here. You wrote this value, 12578D1B. That is the data you wrote here, 1275781D1B. You are reading same data, you can confirm here, 12578D1B. Now what are we doing? Instead of one transaction, we are doing 20 transactions. So what I will do is, in the run.do, let's change it. When I do elaboration, I have to pass here plus num transactions equal to what? 20. That's it. Now you run it, it will generate what? 20 transactions. Okay. Now we should ideally check whether those 20 transactions are happening. They are not happening, right? Something has gone wrong. That is because I'll tell you what happened is, it is called as race condition. What happened is, by the time you passed, by the time it read, it already started this flow. It has already started this. That is where it is going wrong. Rather, if I give a hash 0 delay, if I give hash 0 delay, it will work. 1 second, the generate transaction will happen afterwards. But configure all CSD will happen. Let's say if I don't give it number of transactions I'm giving here, I'm reading in the top all CSD. I'm reading into my MCCSD file, this one, number of transactions. Now when I use this in the generator, I'm using it in the generator here. I don't need to give this. Let's say I give it 20, for example, and I don't pass this option. I'm just trying to pinpoint, is it the issue with the way we did the change? Now if I see this, you should ideally see it is happening. It's some issue with the this update we did that we will check later. Okay, that's not an important thing for us here. What is important here is, you see 20 writes you are doing to some memories here. How do I confirm where I am writing to the memories? Till here I know I did register access, because important thing I am seeing here is, how do I say that this is register access just by checking this thing? Can you tell me? How do I say that? The number 6 means that it is a register access. Anything other than 6 means it's memory access. Not anything other than, it should be 0 for memory access. So from here if I see it is 0, that means memory being accessed. Now you can see what is the data that is being written here. You are writing some value like 12571D, that is coming here, you see writing. Here you are writing to 8D, F9, 8D. You may say, hey, how does same value doesn't reflect here? Why same value doesn't reflect here? Tell me. Can you tell me? It is because it is changes to word addressing. Till now it is byte addressing. When you convert to word addressing, this value will come. You divide this exactly by 4, this value will come. That's the reason. So like that, if you see 20 writes are happening, followed by reads are happening to the same address locations. Reads are happening to the same address locations here. Is this clear to you? Okay. Now what we will do is, next we will move to the other type of memory, that is flash memory. The fourth type of memory, which is flash memory. Top all asynchronous chip select device. Okay. Same thing, I'll copy paste this code as it is. No need of this. Oh, this is a mistake I did in this code actually. I should have put %d. I missed it. This is the mistake. Here I hard coded it to show me %d. That's the mistake. Okay. Now What do I have to do? Again, remove this code, remove these lines. Let's go to one of the previous project code, and I'll just, from there I'll get the asynchronous device connection. This is sync, this is STRAM here. So line number 448 to 458, Y10. Exactly as it is, copy and paste it here. So now, just same process, replace this MCDQ with what? DQ underscore T. If you see, this is what? DQ underscore T. MC address is what? MDIF dot MC address underscore. Oh, okay. Next, chip select is what? MPAF PAF dot MC chip select O. Instead of 3I. Output enable is what? MPAF MC output enable O. Next, write enable is what? Sorry, MPAF dot MC write enable O. Or RP. Again, same thing will be there. MC RPO. These are fixed values. Now you run it. Same test case, only one change I'll have to do is what? Go to the wishbone generator. What am I doing here? Like this, create another test case, Y3. ASCD. Just change it to ASCD. Now the way you created this configure that one, you create another method called as ASCD 74 to 109, which is 35 lines. Y35, just paste it here. ASCD. All that you will see is, you will have to do is, instead of 3 I will have to use 2, because that is what will infer a asynchronous chip select device. Then I have to use this. This is for asynchronous chip select device. Just change this timing parameters now. Now, for this one, which I have to use pulse width, let's say pulse width counter value 6 bits, right? Initial how many bits? 31 down to 26, which will be 6 bits. 6 bits are reserved. 6 tick B0. Next, how many bits? 6 bits. 6 bits are what? 6 bit 6 tick H, let's say 10. Next, counter write disable to chip disable counter value, let's say 4, right? 4 bit 4 tick H8. Next, 4 tick H4, let's say 4 tick H8. Next, 4 tick H8. TRD, read data to valid counter value, let's say 8 tick H10. So like this we use some values. I mean, ideally speaking, I'm using average median values, but you need to refer to the memory, and ideally should get the what value exactly should be configured here. Now if I run this test case, what is the test I have to run among all of them? This one. So what you do is, you create one run.do file. Like this you create this one, ASCD. Okay, just to do run.do now. That's all right. Anything else I have to change? That's all. Now the first thing I should notice is same three checks. Did we connect what type of memories did we connect? Oh, there is a mistake, right? The mistake is we did one mistake here. How can I check that mistake? If you go here, go to the memory instances, you see gen blocks are there. You check gen block 0, you will see what you connected is a synchronous chip select device memory. That is synchronous chip select device. That is because I didn't change here. I should have changed it to ASCD. That's right, it's using a synchronous memory only. Now you run again. So again, same thing, we are writing here, we are reading back here. There's some issue with the read data. It's a known issue, we still haven't debugged it, but we'll check it and let you know this thing. I mean, it doesn't give the data properly. See, one thing you can notice is, writes are happening. I mean, whatever data you write, they are reaching here. See, 8, you're writing to this value, F8, 2, 3, 1F, 1FC6, it is happening. The same thing you can see, but the reads doesn't happen properly. It's a known issue, we are checking that one. I mean, there's some issue with the memory flash loading or something that is not happening. We'll check that one. It's a known issue. Okay, you can ignore this specific thing. So with this, we completed these basic memories. Now, can you write down another four test cases that we can implement here? Minimum 4 test cases. I want you to write down test case and what we can do in each test case. Please think over that. Hello. Yeah. This is serious. Yeah. Yeah. He has an issue. Please ask him to answer another one. Because there is something I must be another. So what do you ask him to hold on to the I will share the argument with you. Please ask him to answer. Everything is there, everything has to share the argument. No problem, you can use the no problem, you can use mine. Yeah, I can share the recording. Whatever session you can share the recording. Okay. Yeah, so what are the other test cases we can develop? Let's write down. We can have test cases targeting mix of other test cases, mix of memories connected. I mean, in this case, so far we checked all SDRAMs, all SRAMs, all flash, and all synchronous chip select. We'll have another test case where we'll have mix of multiple memories, various memories being connected, and checking the chip. I mean, memory controller suspend and resume. Those things we can write. So I'm not going to develop all the test cases. I'm going to leave some of these as an assignment to you. So please work on that and come back to us for doubts. So let's say we want to do mix of memories. So what we can do? So I'll write one implement like this. I'll implement top all memories .sv. So what I will do, I'll just take the same thing, I'll just paste it here. So what am I doing? I use the same code. What I will do is, instead of I equal to 0, I'll say 0 to 1. 0 to 1 means first two memories are synchronous chip select device. Next, line number where to where? Let's see. 137 to 151, which is Y14. Okay. Now what I will do is 2 to 3 is asynchronous chip select device memory. Go here, copy these lines, Y10, paste it here. Next, 4 to 7, 4 to 5, sorry, is, let's say, SDRAM. Somewhere I have SDRAM also, right? All SDRAM. Where is SDRAM? Here. Line number 138 to no, not here. 141 to 152, Y11. Wait, just remove this one. Similarly, you remove this one. You use what? SSRAM here. Now what should I connect? SSRAMs. Down it will be, that is line number 175 from where? 139, which will be 36. So only thing I have to change is, instead of 0, it will be 6 to 7. Is this clear to you? Now, is this the only thing I have to do? No. I have to go to Wishbone generator. I have to, of course, create a new test case like I did here. You create a new test case. All chip select, all mem. Now, you write all mem. Like similarly to this, you create one thing called as all mem. What I will do? 78 to 113, which is 35 lines. Y35 all mem. Now the lot of things have to be changed. Because memories are different, so chip select configuration has to change, TMS has to change, everything has to change. So what I will do is, first, as per our initial thing, this is meant for what? 2 means flash memory. Flash memory is from where to where? Flash memory is from 2 to 3. So I will take 2 to 3 is flash. Same way, 97 to 105, Y7, paste it here, paste it here, paste it here. 0 to 1. 0 to 1, what I will do? It is, I have to use 3 because it's a synchronous chip select device. 0 to 3 is 2 to 0 to 1 is synchronous, 2 to 3 is asynchronous. Next is what? 4 to 5. 4 to 5 is what? SDRAM. For SDRAM, what I have to do? Let's go to the test case below. Which line number I have to change? Let's keep note. 117 I have to change. In 117, all SDRAM. Which is all SDRAM? Here. Just copy paste this line as it is. 137. All SDRAM is where? Here. 4 to 5. Here. Just paste it here. Next, go to SSRAM. What is that I have to do? In SSRAM, you just have to change it to 0 actually. No, change it to 1 basically. Rest everything is same. Okay, that is for CSC configuration. TMS now, program TMS again same way, 0 to 1. Okay. Now 0 to 1, what value you have to configure? 0 to 1 is what? Synchronous chip select device. So again, get that configuration from the synchronous chip select device. Here you will get it. This is which memory? See, asynchronous. This is synchronous. So from here you will get it. Just remove this one. You just copy this line, come here and keep it here. Okay. I'll do one thing, 132, 137, Y7, paste it here. So ideally you don't need this one. Ideally I will need this one. This is for 2 to 3 because this is asynchronous chip select device. Same way, Y6, paste it here, paste it here. This will become 4 to 5. This is 7, 6 to 7. What is 4 to 5? 4 to 5 is SSRAM. For SSRAM there is no need to 4 to 6 is SDRAM. SDRAM, yes, I need to configure. So I need to get SDRAM configuration. In SDRAM, what did we do? This one. TMS is this one. Here. Actually for 6 to 7 we don't need to do because for SSRAM there is no TMS programming. That's all. Rest everything is same. Rest everything is same. Just we need to run this test case. What test I have to run? All mem. Just go to run.to, say all mem. All mem. That's all. Now you run it again. While running, you can also see the coverage results. You see what cover group, what coverage you are getting. All chip selects are targeted except chip select 5. What we could have done for this? We could have, instead of 20 transactions, we could have generated 30 transactions, so it would have got targeted. So generate transaction, what I will do, I instead of targeting 20, go to MC CFG, I'll target 50. Let's say. Other thing what I have to do is here all mem. Let's implement this also. Now I am updating it. So go to the top.sp. You can here I'll say plus num transactions equal to, let's say, 40. If that is the case, you don't need to do it. Let's say I give it 1. I should ideally see 40 happening. Okay, what is happening? Let's see. One zero zero. Just do the transactions. Okay, here we are doing transactions. Not sure. 1 second. Definitely it is taking effect. Whatever we gave, it is taking effect. But only thing is when I'm connecting all the memories, it's not happening properly. Let's do one small change. What I will do is in the top all is mem. And now one thing we can confirm is what memories are connected to each thing. Here SSRAM is connected, 6 SSRAM is connected, 5 SDRAM, at chip select 4 SDRAM, chip select 3 flash, chip select 2 flash, chip select 1 synchronous device, chip select 0 synchronous device, right? Now in this case I will just remove, I'm suspecting flash might be the something that is causing this to go wrong. I'll remove the all mem. Instead of flash, let's say I use synchronous device 139 to 147, which is Y7. 8. Shall I use this? Next I should do is, of course, I should change the programming as well, because we are changing it to, instead of all we are changing it. So I should use, instead of this one, I should use this metadata. Rest everything is same. Yeah, this is about this one. Same thing for timing mode selection. Oh, sorry, there's one mistake we did. It should have been 6 to 7. 6 to 7. 6 to 7 we did. Let's see if I run again. Let me run again. In the I'm reverting back to case where all memories are connected. I'm just checking with that again. Yeah, now it's working. I mean, the issue was with some of the SRAMs were not configured properly. I mean to say, we did not change this number properly in the Wishbone Gen. Here we didn't keep 6 to 7, we kept 4 to 5. So it was overriding the previous value. So anything you target to 6 and 7, it won't work because you didn't configure. Earlier I had 4 and 5 here. So that was the issue. Once I fixed that, it is working. Now you see, we are writing to some locations and reading back from some locations. Only reason why you see it is probably not working is, wherever you see red means, there you are accessing probably flash memory. If I see here, what I will be, if I go down and check, what am I checking there? What am I accessing there is MC chip select. If I see, what is the memory I am selecting? 0. If I am selecting 0 is what? Synchronous chip select device. Here. Actually, we need to confirm on this thing basically. I mean, basically we need to go transaction by transaction and see where are we missing. Actually, here it is happening properly. No, it's a mistake. Here it is happening properly. You can see the data. 1027, it is happening properly. At chip select 0, it is happening properly. That means here it is good. Here it is bad. You can see completely X. That is where you can see that which is the chip select that is targeted. 3 is flash. So it is a known issue. We have a known issue with flash memories. So that I'll fix it. I mean, I'll take a look into it sometime and come back to you. So do you have any questions here? So like this, you can check all the concepts, like I mean, whatever other memories you are writing. Let's say you wrote some memories here. Are you getting the proper values? Let's say, what is the memory here? You just take randomly this location. You are getting what data at 0, 5, F2, F9. What is the value data you are getting? C3 to ED13. Just remember that 5F2, F9. 5F2, F9, right? So when we wrote, what value we wrote? Let's check. 5F2, F9. Somewhere it should be there. 5F2, F9. Okay. From here read started. Let's see. 5F2, F9. Let's check. here. Here it is right. 5 F2 F9. What data you wrote? We wrote. What is the chip select there? 6. 6 means SSRAM. We wrote 5B 4EE FB9. We wrote that 5B 4EE F9. Let's again minimize it. Somewhere here we did that. Here, right? Let's check what value you are getting. C3, it is not matching, right? Whatever data you wrote, it's not matching. So we need to debug these things. Why you are not getting the same data? I don't have an immediate answer for this. We need to check and we need to sit and debug. Is it working properly? Not all those things we need to check. What is the data here? 6 BD A279. 6 BD A279. There must be a way where you can search a pattern here. Search, yeah, 1 second. 817 CBE4. See? So what is the value you read? Let's see. It is 6 BD E5. Okay. Let's see. Now here it is different value. Let's check further. Yeah, C32, data I are you seeing somewhere? Let's see. 5B4 EEFP9. If I take this, are you reading same value somewhere? Let's check. It is never read. Whatever value you wrote here, you never read it. So let's check which is the chip select targeted there. Which is the chip select? Chip select 6. So this is something we need to check. And chip select 6, why we are not getting the proper value? We need to check this. Okay. So again, what you can do here is, you instead of all memories, you change it to first only 2 types of memories, SDRAM and SSRAM. So you see, you know that all SRAMs, all SDRAMs, all flash and all MEMS, except for all flash, everything work. Now you mix SDRAMs and SSRAM, you see. Similarly, mix SDRAM with synchronous chip select device. Like that you start doing, increase the number of transactions. Like that you start debugging it. Okay. Next thing is memory monitor part. So do you have any questions till this point? I'm sorry, we'll start with the session now. Okay. Any doubts in whatever we have done so far? Okay. So next thing we need to do is improve develop more test cases. What else we need to do? Update the reference model, memory monitor, and checker to support various memories. So what we have to do is, no need of Wishbone gen now, no need of all mems now. In the MC config, no need of this. I'm in a session. Okay. MC ref. It is in here, right? We already opened it. So this part I need to update. We need to update. Other than that, we need to update ref MC. No, not MC. Mem monitor. This we need to update. Right now you see it has been only implemented to support SRAM. You see what is this implemented for? It's only supported to support SRAM. Now how do we support SDRAM? So that is where, please go through this code once, what we have done for SRAM. We'll try to implement the same thing for SDRAM. We'll try to implement the same thing for synchronous select device and other things. Okay, now we have implemented this for SRAM, right? Same way we can implement the same thing for other memories also. Let's say synchronous chip select device I have to implement. Now what I would do is here, as soon as you do it, you implement this logic. What I will do is chip select is there, right? Yeah, here. I would do chip select target. Yeah. CS target equal to get CS target of MVAF MC chip select. I'll do one thing. I'll save this content code somewhere, because if we do something wrong, we'll always have this backup. Memory controller space. Now, what is this function will do? We'll write. We will implement here. Function bit 2 down to 0 gets chip select target. End function. Bit 2 down to 0 chip select. Okay. No, it is not 2 down to 0, right? 7 down to 0. What I would do? Case CS, let's say. End case. 8 tick B 1111 1110. Return 0. That means chip select 0 is selected. 0 0 0 0 0 0 0. So if this is the case, return 7 6 5 4 3 2 what if all are 1 means no chip select selected. So what I would do is return 3 down to 0. I will return 8 if this is the case. 8 indicating that no chip select is targeted. Any other case, default means any other case, I will display error. $display error. Multiple chip selects are targeted at the same time. It's an error scenario. Anything other than that, if happens, that means you are doing a wrong memory controller is doing wrong. Now, why this chip select target will be used? So I will declare here bit 3 down to 0 CS target. So here now I have to write from here. I need to get chip select target 2 down to 0, because even though it is 3 down to 0, bit number 8 was only for checking that it's a wrong chip select. I mean, no chip select is targeted. Among 2 down to 0 will give the actual values. So if we take 2 down to 0, that will tell us CSC value. Declare here again a field by name CSC value. Bit 31 down to 0, CSC value. That is this one. Now what do we do with the CSC value? Case CSC value of which register I have to take? Three down to 1. End case. If it is 3 tick B000, what I should do? Okay. Y1. If it is 01 means 1011. If it is 01 means I have to do SRAM, that is line number where to where. 44 to 59, DE15. You just paste here. Is this clear to you? What am I doing now? So this indicates that it is of type SDRAM. Rather, I could have written SDRAM also here. Just write SDRAM, sorry, SSRAM. In the top, in the MC config, go to top, MCCFG, change SSRAM to, you say, tick define SSRAM equal to 3 tick B 001. SDRAM is 000. Back, synchronous chip select device. Asynchronous chip select device. It is 1011. Okay, this is what we do. Now instead of this, what I will write? Tick SDRAM. Next here, instead of this one, what I will write? Tick SCSD. ASCD. Now, if it is, sorry, SDRAM, I did a mistake, SDRAM. If it is a synchronous chip select device, what I have to do? Let's see. If it is a synchronous chip select device, you go to the operation, you will get to know what you have to do. It is SSRAM. It is synchronous chip select device. You see, in synchronous chip select device, in case of read, what you need to do, in case of write, what you need to do, it's written here. Let's see. How do you know that write is happening? Based on this. What you have to check, if MVIF write enable is low, if MVIF MC write enable is equal to 0, right? And that's all. That is enough. If I check that, it indicates that we are performing a write. This is write. Next, what I have to check? At the same time, whatever address is there, whatever data is there, I'll capture that. Whatever address and whatever data. Otherwise, I can wait for MVIF MC acknowledgement. MC acknowledgement. Let's open top.sp so you'll get to volume. I equal to 0. We will wait for this to be equal to 0. Sorry, equal to 1. So at that time, whatever is the data, what I am doing is, at this point, whatever is the data, whatever is the address, whatever is the data, I'll capture those two things. What am I doing? At that point, whatever is the address and whatever is the data, I'll capture those things. So what I will do, similar to this, exactly same thing, line number Y4. I just copy these 4 lines, paste it here. What am I doing? I'm creating new transaction. I'm putting tx address, tx write equal to 1, data equal to MC data. That's all. If it is read, what I have to do? Line number 55 to 63, Y8. Just paste it. You say it is read. Instead of write enable, what is the difference between write and read here? Instead of write enable, I have to check for output enable. Just say OE. Next thing is, again you wait for acknowledgement. Only one change I have to do is not there in the next positive clock edge. See, as you see from the diagram, immediately at this edge data is not valid. At the next positive edge data is valid. So what I will do is I'll wait for clock, MC clock. At the rate of positive edge of MVIF MC clock I. So is the clock I proper? Let's check from the top.sp. No, it is mpf.clock actually. mpf.clock itself. The naming is wrong. It should be CLK only. Now instead of data O, what should I take? Data I. The rest everything is same. Is this clear to you? What are we doing for synchronous chip select device? The same thing I will have to do for SDRAM also. Now what is the starting point for that? Again go to the SDRAM timing diagram. In SDRAM how writes will happen, how reads will happen. So it will be a little tricky portion because you need to check the RAS, CS, write enable. Based on that you have to figure out whether it's a write or read. I mean there is nothing called as write or read in SDRAMs. There is no separate port called as write enable or output enable. You have to go by RAS and CAS and write enable. So what you have to do is, in case of this one, you have to check if mvaf.mc RAS and equal to 0. So let's put a condition here and mvaf mc cas equal to 0 and mvaf.mc write enable equal to 0. Some conditions. This will tell whether the write is happening or read is happening. I mean these conditions will tell us. Now what I have to do is you need to check what is the read condition, what is the write condition. So for that what you have to do, go to the specification. Base course material memory controller object is Samsung operation timing. So if I go, timing diagram will be there somewhere. One second, there will be one truth table. Here, somewhere here. Okay, not this one, which will tell whether it's right. When does write happen? When does read happen? It will tell us. I'll tell you. Otherwise, let's do one thing. Let's check SDRAM truth table. No. SDRAM commands. I would say 1 second. It will tell us command table. Let's just check once. So what you need to do is, there will be a table here, you see here. It will tell it will tell us when does the write will happen. You see, when write will happen when these conditions are met. This should be high, RA should be high. Plus. Okay. You go on. You go on. I just okay. So now we have to implement HLL. So what I have to do for write, what is the case? For write, RA should be high. This is write case. For read case, what is the case? Y2. Sorry. No, this one. Read. Read, when read will happen? Read will happen when high, low, high. High, low, high. No, is it same thing? Right is high, low, low, high, low, high. Yeah. I have to write high, low, high. Yeah. This when read will happen. Now what will happen when write happens? The same thing. If you go to the spec, you can see write will happen after write will happen immediately. There you need to know what is the burst BT, burst length. So it will be little tricky. I mean, it's not straightforward. You need to know is it a burst transfer. Then you need to know how many bursts, how many length, what is the length of burst. Accordingly, again, whatever you did here, you have to do whatever you did. Same thing you need to do for the synchronous chip select device also. Yes, again, going back to MC reference model, you will have to do the similar update. The way you updated for SSRAM, you will have to do the similar update for like you see here. This is again, instead of this, replace it with what? TIC SDRAM. You replace it with what? TIC SSRAM. Similarly, replace put another case for SCSD. SCSD. This is ASCD. Okay. Now again, I would say SCSD would be pretty much same. Okay. SCSD would be pretty much same. SCSD would be pretty much same. So what I have to do here, it would be same as SRAM. Copy line number Y5, just paste it here. So instead of this, it is SCSD. It is ASCD. Okay, I hope you got the details how we are doing it. And now tricky part will be how you are going to do it for ASCD and SDRAM. I mean, the point is how we will analyze wishbone transaction and convert it into memory transaction with the bank address, row address and column address. How are we going to do? That is something you need to work on it. So from our side, we will stop with the project here. We have shown you how to create multiple test cases, how to implement the checker, how to implement the monitor. We have already done some other checker implementation as well. MC checker won't change. It would still be same. So I would suggest you take it from here and you implement the other aspects of the project. Okay. So with this, we'll complete the memory controller project. Now I will take up any questions you have. From the next week onwards, we'll start with the AXI verification IP, AXI protocol and AXI verification IP. Okay. Any questions you have? Okay. So again, please note, if you just attended my sessions, you would not really understand. I mean, you wouldn't really learn anything. You need to practice. Please practice whole complete memory controller test bench development. Okay. So we'll plan for a lab session. We will plan for a lab session on memory controller. So that time, before that, if you can practice that, it will be good. It will be good. Okay. Any questions you have got? Okay. If you have no questions, we'll end the session here. Thank you.